the getting should be well designed, that it should avoid every things or core erosion, or reducing usual velocity within the cavity, and avoiding direct impingement on mold walls or cores. Two, the flow of molten metal to the mold cavity should occur with as minimum as possible turbulence, because if turbulence is excessive, the aspiration of mold gate will occur, which will oxidize the molten metal. The oxide so formed separates more or less completely from the melt and forms a dross, which is an impurity on your non-ferrous castings. So dross are the impurities you get in your non-ferrous casting, while in ferrous castings you get slags, you know. So to pick up direct slag to pick up draws or slag, the getting system must incorporate slag or draw traps. The getting system must eliminate turbulence by use of a well at the sprue base, avoiding sharp changes in the direction, filling the mold at the lowest point, using the optimum size ingot, filling the mold quickly, whereas ensuring that metal flows in. The excess metal absorbed in gates and risers should be minimized. Various parts of a gating systems are discussed in the following sections. So these things we have talked about are how these gating systems are, why they are important rather in the mode. Uh, the pouring basin. So let's talk about the systems and their parts. So let's start with the pouring basin. They say this part is made on or in top of the mold. Molten. This part is made on or in top of the mold. The molten metal from the ladle is poured in the pouring basin, and from here the metal flows to a various parts of the mold. The pouring basin or cup is an important part of gating system, and the design of this component has been excessively discussed in the literature. Most important aspects of the cup or basin designs are, they say the most important are: one, they must be large enough so that the gating system can be choked rapidly and maintained full. They must be deep enough to permit vortex functions, and they must be placed in a location such that the handle can be brought near to it and the metal poured in steadily without turbulence. The sprue. So after the pouring basin is just made to collect the pressure first of the molten metal. So instead of you pouring direct on top of the cavity, when you do that, it will wash away the mold walls. So you have to apply your gating system, which you start from your pouring basin. So the pouring basin comes in a funnel shape size. So now it collects the pressure from the um, pouring time of when you are pouring your melted metal. The pouring basin correct the pressure. So this is just the benefit of it. So it collects the pressure, reduce the turbulence, and reduce molten metal wall wash. The sprue. This part is a downgate or vertical passage through the cope. It connects the pouring basin to the runner in the gate. The basic requirement of a sprue are as follows. One, the size of the sprue determines the rate of the flow of metal in size. Therefore, should be small enough so that metal in the mold cavity with less speed and chattering and turbulence are avoided. The size, however, must be large.